Hello, everyone, and welcome to the Python Exchange. My name is Cameron Riddell, and I will serve as your host for today. We are also joined by our usual crew of host panelists, whom I'll let introduce themselves in just a little while, because first, I want to shine the spotlight on our important guest panelist, Yuvi. Yuvi has been a JupyterHub core team member for close to a decade and is a co-founder of 2i2c.org, a nonprofit serving users with interactive computing needs through open infrastructure. He is the co-creator of Zero to JupyterHub, kubespawner, and the littlest JupyterHub, mybinder, Jupyter-server-proxy, and many other Jupyter projects that you probably have heard of at some point in time. And today, Yuvi is here to share with us all about the features and capabilities that JupyterHub has to offer outside of serving the popular notebook and lab interfaces. Yuvi, it is an absolute pleasure to have you join us today. You'll also notice that we are joined here by a couple of individuals whom I'd like to now give the opportunity to introduce themselves to our audience. So let's go ahead and we'll start with James, and then Dan, and then Phil. So James, you'll be up first.
Hi, everybody. I'm a regular host panelist of this event. My name is James Powell. I work together with Cameron on a number of different things, as well as together with some of the fine folks at BNL, most recently on some projects investigating how we can better use AI LLMs. I think those are kind of popular these days for actual useful projects within the scope of beamline physics.
Absolutely. And James, thanks so much for joining. It's always a pleasure having your opinions and questions here on the Python Exchange. Dan, you're up next. Can you go ahead and tell us a little bit about yourself?
Sure. I lead the data engineering group at NSLS2 here at Brookhaven. I have been a longtime fan of Jupyter Notebooks since they were called IPython Notebooks, and have been running JupyterHub at NSLS2 since I was a postdoc. I think we were very briefly in the running for having one of the largest JupyterHub deployments until we were quickly surpassed. But we were early fans here, so I'm especially looking forward to this talk.
Awesome. Well, it's always great having an early adopter. I'm sure you'll have plenty of phenomenal, hard-hitting questions for Yuvi. And last but certainly not least, we are also joined by Phil. Phil, can you go ahead and introduce yourself for our audience?
Yeah, absolutely. My name is Phil Maffetone. I am a regular troublemaker at NSLS2, mostly causing problems and solving those problems in the space of artificial intelligence and robotics. That's about me in a nutshell.
Excellent. Well, Phil, it's a pleasure to have you here. Hopefully you don't cause too much trouble for today, but at the very least, it sounds like you're able to put out your own fires. All right. Well, to officially launch us into the exchange, I'd like to turn over the metaphorical microphone to our guest of the hour, Yuvi. So Yuvi, go ahead and take over.
All right. Thanks for that intro, Cameron. I really appreciate it. Happy to be here. So I'm Yuvi. I'm one of the maintainers of the JupyterHub project. I'm also the co-founder and tech lead of 2i2c, which is a not-for-profit that operates JupyterHubs for various institutions, as well as contributes like heavily upstream. And this talk is really, like just sort of talking. It's going to be very demo heavy. And sort of talking about how the Jupyter part of JupyterHub is really a misnomer, and how much we have moved in sort of like the 10 years JupyterHub has been a project doing random things. So this is how it was described in the announcement in well, I guess I was about to say about 10 years ago, but it's more than 10 years ago now, time flies. But, and I also, for the people here who may not know what JupyterHub is, right, I thought I will give you sort of like a quick demo of how that looks like in general. So I'm going to use a hub called CryoCloud Hub. It's operated by a team that is run by Tasha Snow for a lot of, ice and snow-related researchers. This is how that looks like. You log in with GitHub, and then once you log in, you get, this is a configuration that's going to be different for each hub. It's going to be tuned to their own needs. You can select kind of an environment, including you can write your own environment in, and then you can select what kind of resources you would like to have. There's a separate one for GPUs, and you hit start, and basically, you end up it sort of like starts up a server for you that usually is a Jupyter notebook, right? It's like Jupyter Lab or like a classic notebook that you then go and do whatever kind of thing that you want, right? Like usually it's like you're like opening a Python notebook and then doing random Python things that one does in the world. So this is what JupyterHub traditionally is, right? Like this is in the cloud, you have your home directories, you can access like whatever things you want, and researchers and students use this. But let's, like, as you can see, as you'll see throughout, like this is not all that it needs to be. So 10 years later, this slightly complex diagram is, this came out of the JupyterHub Leadership Summit that happened a few months ago. And this is sort of what I think of as JupyterHub now, which is, web-based data access, web-based access to data science tools, no matter where, right? And also importantly, no matter what kind of tools they are, not just notebooks, because notebooks are helpful for, some subset of users, but not for everyone, right? People want to use VS Code. Our users want to use RStudio. There is a lot of Linux desktop stuff that is still very valuable. And, there is lots of things that are very domain specific that has been built by someone like QGIS or OpenRefine, like that you would need to do. And it will also run in lots of different places, right? It could be on a HPC center. It could be in the public cloud on AWS or any of the European clouds or just a desk under a server under someone's desk. But for a user, they can all be unified as a JupyterHub interface. But more importantly, for administrators and people setting it up and running it, it can all be run as JupyterHub, so that instead of building a separate set of tools for each of these combinations, you can use one tool with a broader open source community and use that for everyone. And this has sort of been one of the major evolutions of JupyterHub in the last 10 years. So right now, the way that this is implemented is through this project called Jupyter-server-proxy that Ryan Lovett at UC Berkeley and I helped start many years ago. And the idea is that, like you can safely expose any web app from your JupyterHub. And it really does three things, which is, like it starts a process that listens on a port or socket or a Unix socket for HPC type environments where you don't have containerization. Proxies external requests to it, with authentication. And then, you can also optionally give it a user-friendly name and an icon so people can just click on it to start it. Let's work through demos to show you how this actually works instead of me trying to describe it. So the first demo is, I'm just going to create a file. I'm going to just copy the Flask quick start because I am lazy. So Flask is a web application framework. So I have copied. I'm going to increase the font size. I'm doing lots of demos. So if I get more than a 50% hit rate on the demos, I'll be happy. But let's hope it's a higher number than that. So demo.py. Right? I'm going to increase the font size a little more. And then I'm going to open a terminal. And there is a command to run this, right? So this is a JupyterHub. It's running on AWS, right? And I have, it's called demo, not hello. So this is running in a remote server somewhere, right? Not on my local machine. So if I click this, that's not going to show up, right? Because that's not where that is. Jupyter-server-proxy basically lets you construct a URL to access that. So it's probably a little hard to see, and nobody really constructs these URLs by hand. I'm just using it as a way for you to see what's going on. So I think it's 5,000, right? So you can see here that what I have done is I have used the URL structure proxy/port number, and that will proxy it to that particular port. And you will also note that this is sort of authenticated. If I open a brand new browser and then go there, it just bounces me off to the login screen, right? Because I'm not authenticated in here. So we didn't add any authentication code to our Flask, right? It's just the proxy in front that uses all the JupyterHub mechanisms to authenticate. So this is really, this is really the core of what Jupyter Server Proxy does that enables all of this other work, which is, we started a process that was listening on a port, and then we have a URL structure that lets you see that. This does help you do quick web development, by the way, in JupyterHub if you so want. So if I say hello world, this will, I don't think I need to run this again. And then if I go back here, I can see that. So you can use this for developing web applications or teaching how to develop web applications in various ways. So that's quick demo one. Now let's move on to something more fun, which is OpenRefine. So the OpenRefine is an example I'm going to use of a web-based tool that doesn't know anything about Jupyter at all, right? So OpenRefine is often used by people to clean up pieces of data. It's a very popular project. It's not really used so much in the data science world as much as more in the sociology / qualitative sciences world. But it's also still people working on data and doing cleanup and work like that, right? So if you want to give people a JupyterHub that just runs OpenRefine, right? Like, let me do it manually here so you can see what that actually looks like. And then I can show you how JupyterHub, Jupyter Server Proxy lets you configure this easily. So I have OpenRefine downloaded here. So I'm going to just say refine. I know it's /h*, which is just turns off its own authentication because Jupyter Server Proxy does it for you. And then I'm going to give it a port number, which is 4000, which I think that works. Yeah. So now go away screen. Okay, let me try to magically go to the next tab. All right, I moved it. So if I go to port 4000, so this gives me OpenRefine, right? Like I can browse and upload pictures from here. And basically, generally, I'm not going to like give you an OpenRefine tutorial, but what I want you to see is that, so this also allows for people who want to do some things in OpenRefine and some things in JupyterLab, right? Or some things in RStudio. You can just sort of like move things around. And from an end user perspective, they don't really see anything Jupyter related here, right? Like there's no JupyterLab, it's just OpenRefine that looks like it may be running on their laptop, right? But it's just like a hosted setup. So to go back to what I said earlier, this means you don't have to build a multi-user OpenRefine project, right? You can just use JupyterHub and then just use OpenRefine as the UI. And instead of having to go to the terminal and then type in the command, Jupyter Server Proxy, I'm not going to go too much into the detail here because you can read it in the docs. But there is multiple ways you can specify this, right? You can create a Python package that people can install that just has the commands that it should run. Or you can also just specify directly in config in your JupyterHub, so you don't even need to create a package. And what that will do is it will create like an icon that people can click. Obviously, that none of these are the OpenRefine icons, but it'll create an icon that people can click so that they can just like go through there. But even this can be too much for some use cases. Like you don't even want to see the Jupyter interface at all, which is totally understandable. So here's another demo from the University of Toronto, which is one of the other universities we run hubs for. So this is their landing page for their teaching infrastructure. And you can see that it's like, right, you can just log into any of these, right? Like they don't really mention JupyterHub as its own interface. They just mention it as like a thing that will run any of these things. So if I click log into RStudio, you can see that, it just starts the server for me, and then it directly puts me into RStudio, right? There is like no Jupyter things here. But for us as people running infrastructure, this is just a JupyterHub instance with RStudio installed in the container image and the correct Jupyter Server Proxy package. But for the people teaching with this, they don't really need to touch Jupyter at all. Almost all the R users I know use RStudio, and this is a way for us to really support them in like a really first-class fashion without them, like having to deal with like all of the Python stuff that is like pedagogically pretty inconvenient. So this to me is the magic. This is what really like helped like spur Jupyter Server Proxy development. When I used to be at Berkeley, we were really trying to support our R users, and from talking to the users, it became really clear to meet them where they are. We needed to really support RStudio as a proper first-class citizen and not as an afterthought. And I think our support is there right now. So that's the RStudio demo. And then, with time, people started making random proof of concepts that then just sort of got a little out of hand sometimes. And so one of those is, let me start and stop this, is a Linux desktop environment. So this is the NASA Veda project, which is a project that we help run a hub for. And they have a lot of data on the cloud, right? That's adjacent to this. And some of their users want to use GIS software like QGIS to access this data. So instead of just setting this up locally for them, right? But then you don't get the direct access to S3 from here. You can just set this up. This is a Linux desktop environment. This is accessible to everyone on the hub. And QGIS is set up here. And you can go and do QGIS things, right? I don't know. I don't really know anything about QGIS, but you can, all the QGIS things one can do here. And this is helpful when you want to sort of like lift and shift people's existing workflows, and then slowly move them towards other kind of workflows, right? Like, and it's always helpful when you can just get that started. And get people going without having to do a lot of re-education or retooling of like workflows. And this also means that you can control the version of QGIS, you can maintain your images, you can do all of that without a lot of heavy work. And there is a lot of other things you can do here with the Linux desktop because you can still let people use Macs, right? Like I don't want to sign up any IT team for managing a huge fleet of Linux desktops, but I'm totally fine doing that here for specific tools. And you can also do some other really cool things where you're sort of like pausing, because now this has brought Linux desktop onto the web as sort of like a thing that you can do URL things with. You can integrate some Linux desktop tools into other tools that really are web-based. So this is the, again, from the NASA Veda project, this is the Greenhouse Gas Center. This is their web-based tool for basically doing demos, for basically exploring various greenhouse gases stuff. And one of the features they've added, right, is like I've added a layer of something here, and then I can go load into GIS. And this has like, yeah, sure, there's like tile URLs and stuff if you have QGIS locally. But I can also click this button, and this is really quick because I already had this open. But you can see that it opened QGIS, right? And then it loaded up that exact layer over here. Right. And then as a person who knows about QGIS than I do, you can go around and explore this layer more as you would like. So the way this is done is you can see that, in the URL, we have like, QGIS and then action equal to something, something. And there is some Python code that inherits from Jupyter Server Proxy that, interprets that in some way and does whatever that QGIS needs to do to open it using its API. So, and because Linux Desktop is pretty scriptable, you can use this to really automate a lot of workflows in whatever way or form that you want, and again, be able to lift and shift workflows, as well as just use JupyterHub instead of having to use, like a separate VM provider or whatever for a specific subset of like use cases. This is the one that I find most cool and sort of like wild, because, I mean, the latency on this is super acceptable, right? Like this is pretty far from me, I think, and this is fine. This is like a usable speed and latency for like something that is a GUI. So I'm pretty happy with it. Let's see, what was the next demo? Is SSH. No matter how much GUI stuff you have, we will always, I think, need terminal-based access. And that is also something that we can do because, like we just proxy things together and we can run a full OpenSSHD server with everything that entails here. So this is another hub we run called Leap for the Leap project out of Colombia. And I've started my server here. And what I'm going to do, and hopefully people are, I think people can still see my screen. That is the VS Code screen. If you cannot see a terminal, please let me know. So I'm going to SSH into this hub, right? And I have my credentials and set up, and I'm there. This is me SSH'd into my JupyterHub, which means that it's not a single machine, right? It's like a bunch of containers in this case running on a Kubernetes cluster. But from the user perspective, this is just SSH. And all the SSH things just work. So I can say, touch, this is from SSH. And if I go back to the browser, I can see that, right? This is from SSH. I can, and again, if I go back to the browser, to the terminal, I can use Vim, right? And that's also going to be here. And this extends, and because we are not re-implementing SSH, we're just using OpenSSH on the server, you can do SCP as well. So touch this file for SCP, and then I can do SCP this file for SCP, leap.directc.cloud, this file for SCP. And it's copied over, and I can see that here, this file for SCP. SFTP also works. And the other thing that works is, with VS Code, you can connect to the remote server. The VS Code remote development extension is not open source. VS Code has been slowly getting more and more proprietary, and this is one of their proprietary extensions. But you can see here, I have connected this, like I didn't need to modify anything in VS Code. This is just the default SSH based. You can see SSH leap.2itc.cloud. And you can see on the left all of the things in the home directories, including the files I had just created, right? So I can say, like this is from my local VS Code. And I save it. And then if I go back here, what file did I save it? This is from SSH. Right? So you can see how by just adding support for SSH, it really unlocks a lot of use cases without the admin having to do anything else, right? Like you could do this for a multi-user scalable setup with SSH, but you would have to basically develop that tool separately, and then it can only do SSH, right? But instead of that, everything is just on JupyterHub. And it should just work like, all right, AWS, wherever this is running, right? Not just cloud providers. This can run in most places with some security caveats we'll come to later, but they're fairly minor, I want to say. So SSH is also really cool. It enables a lot of use cases. And to me, it really brings out the fact that JupyterHub is not really just for notebooks. It is for people who wanted to basically do whatever it is they want to do, right? It really is a way for admins to just provide environments at scale in a way that is easy to administer. So where is my slides? Here's my slides. So the last demo is, as I mentioned earlier, the version of VS Code that you download is not open source. It's proprietary, but there is an open source version called Code Server that can be hosted directly on the web. So if I go back here, you can see it's just VS Code. If I click it, it will launch a VS Code. It basically looks like VS Code to you because it is. It just doesn't have the proprietary stuff that Microsoft puts in there. This is maintained by the community, and they basically take snapshots of the code and then make changes. So this means you can provide a more IDE environment rather than a data science type environment with VS Code, with Code Server in the browser without the end users having to download anything. So this also means that you can have this hub set up, and people who want to use their local environment can do so, right? And still have access to their files, to the environment, and most importantly, if it is close to any large amount of data, to the data. Versus people who don't have a local VS Code environment, they can just come up here and do that. And because it's SSH, you can, like, people who want to use Tramp with Emacs or just SSH in and do stuff can also do so without necessarily needing to do anything. Hopefully we'll share these slides later, and they should have the different packages that provide these functionality, and they'll all have bits and pieces documentation on how you can do that. So that's all my demos. I think I hit all of them, that feels pretty good. I didn't, that's quite nice. There's some limitations, right? So the major limitation is that while Jupyter-server-proxy does enforce the authentication at the network layer, you still, for some subsets of network security, right? Basically from other users on the JupyterHub, if you are in a containerized environment, you're like totally fine, right? Because all your process will listen on localhost and nobody else will have access to that. But if you are not in a container environment, you would need to then basically have your own network setup that prevents users from being able to talk to each other on your local servers. And that can be either through some other form of containerization or through your own firewall setup, or Jupyter-server-proxy also supports Unix sockets, which will be able to give you some amount of isolation by just doing user permission enforcement. But then the server you're running also needs to support Unix sockets, right? Someone just added that support to RStudio because they wanted RStudio on these things, but that is a limitation if you don't have any form of containerization, right? And the second is, it requires Jupyter-server-proxy to be installed in your user environment. And this is a problem, or this is just like an additional complication in case, you want to allow your users to bring any kind of environment that you want. So I'll come to the next slide to talk about that. And then the third is that your web app needs to support running under different base URLs. This is just like a web app good practice, honestly, right? Because you want your web apps to be able to run under just www.myapp.com, but also under myapp.com/Yuvi, right? And some apps don't support that because they always assume you're running under / but most apps do, right? And if they don't, they usually accept patches or a bug report that supports that. I think that's good web design practice to be able to do that. But that is a requirement for it to work here. But I think these are pretty okay limitations. They currently still enable a lot of heavy usage that really enables a lot of use cases. And for the second use case, there is a blog post that I had published a few days ago. This also came out of the JupyterHub Leadership Summit, where we are looking for either groups of people or funding who want to basically remove limitation 2, which is to just re-architect JupyterHub a little bit so it doesn't require Jupyter-server-proxy in the user environment to be able to do this. And that has technical positives, but it primarily has social positives, so that we can fully say, because Jupyter-server-proxy is a Python process, right? So that means even if you want to purely support our users, you still, as an admin, need to maintain a Python environment in there. And so this is sort of like, we're looking to see if we can eliminate that, and then fully, properly treat them as not just first-class citizens from a user perspective, but also from an admin perspective. So that's that. And then that's the end of this. The Jupyter Zulip, which is the real-time chat system, has been pretty active for the last year or so now, I think. And it's been a great way to connect with people. I highly recommend hopping on and asking questions, talking about any of this over there. And I promise you, it's a better experience than Slack. So, and it's public and open to everyone. But I think that's all I got. Thank you so much.
Fantastic. Thank you so much, Yuvi. That, I have to say, not just one demonstration, but 6 different sequential demonstrations and no errors. I'm very impressed.
Thank you.
Let's go ahead and jump into our Q&A. So we'll open up the Q&A for our audience as well as our host panelists. And so host panelists, feel free to go ahead if you have a question off the top of your head. And if not, I do.
I got so many, so I will go first. Yuvi, what evolved to make the desktop through JupyterHub something that feels solid, has acceptable latency, is more than one weird trick that kind of works?
Yeah, I mean, the driving force was when the pandemic started, and then we had to move all the classes, to the cloud. There were some electronics classes that just, you would design your circuit in code, but it would pop up a QD window with the demo, and we had to move that. So that's sort of what drove that initially. And then afterwards, it just turns out that web VNC is like something that has a lot of resources put into it in the world, because like that's just a thing that cloud providers offer for you to go debug. And we're like, oh, we can just piggyback on this and then work pretty well. So that's basically that's what initially drove that. And then that being able to reuse that technology stack made that so much easier for us to be able to build and manage. And then eventually QGIS was actually our driving force for making that more popular, because as more and more of NASA's data moves into S3 and gets bigger and bigger, and we are like, right, let's put our compute next to where the data is. Sometimes that compute is QGIS, right? And so for some subset of users, being able to load gigabytes of data onto QGIS from S3 very fast was a very helpful use case. And so that's what allowed us to get more resources. Development Seed is a wonderful organization. They're very very involved in the GIS, geospatial world, and they had enough use cases to be able to invest resources into getting that QGIS stuff to work. And that's also why that other cool demo of us being able to click there showed up. So does that answer your question, Dan?
It does. I will sneak in a follow-up. If we have a VDI license, Horizon Virtual Desktop Professional Solution, is there a particular category of use cases where the hub makes a lot of sense? Is it basically if you've also got a notebook and you're using these action URLs?
I mean, to me, it's like from an administration perspective, right? Like, do you want to manage 2 things or do you want to manage 1 thing, right? And in some cases, it's like becomes a question of consolidation, because some people have VDI and they just use that for notebooks too, right? And that works as well, because they don't want to manage like these 2 things. So it really, at that point, to me, it becomes a question of like, what as an admin do you want to do to make your life easier? Because there's lots of ways to configure that in a way that works well for your users, but what works for admins is the question that needs to be answered there.
Thanks.
Awesome. Next up, we'll have James, and then we got a couple of questions from the audience as well.
I actually have a question for our BNL colleagues, Dan and Phil. In your environment, as I understand it, the experimental work is very important, which is why you have groups that are dedicated to just control, and why you sometimes see odd combinations of skill sets among the scientific staff somebody who knows NumPy, but they also know PyQt really well. What I'm not certain about is when we're talking about experimental hardware control and the interfaces for those, it seems like historically the approaches are PyQt custom GUIs or web-based custom GUIs. Is there any use of these Jupyter Lab plugins or these Jupyter Lab extensions on the controls side of experimental work? Like, would you use a Jupyter instance to control hardware or to run an experiment?
Yeah, the question is clear. I can't think of an example of Jupyter widgets or Jupyter extensions being used to control hardware. Sometimes Jupyter notebooks are used to run experiments. So it's possible somebody made a widget and I haven't seen it. Phil?
Yeah, I think that's kind of the example there, because we essentially use IPython for orchestration. I wouldn't say direct hardware control, but sort of like larger Python instructed orchestration, right? You can easily use Jupyter Notebooks to engage. It runs some interesting challenges with cell execution order and things like that. But I see where you're going with this, James, and it's an interesting thing. I think a lot of our direct sort of engineering UI is managed by, or it leverages like the Epix collaboration and what those teams are doing, and there's some movement to different types of tooling. And I think the biggest challenge would just be the network isolation that we like to provide on hardware versus what we provide on our data access. So I don't think right now our JupyterHub has access to process variables and engineering controls of hardware directly, where our JupyterHub is provisioned with access to our data. And it took a reasonable lift recently to have a VDI instance where you can actually spin up a VDI workstation with access to the engineering variables.
Is there a reason for this? Because what we see from the demos that Yuvi shared is the idea of a Jupyter instance as more than just an analytical toolkit, but generalized across any UI development. And it's a heavy lift to ask a physicist to write PyQt code. Is it less of a lift to ask them to extend a Jupyter environment?
Yeah, I see that. It's a good philosophical question, and I think Yuvi makes a really good point. I made a good point in his last few slides, right? It says, treating your end users as both the physicists who are getting down to the weeds and also the sysadmins who have to go gray because of the end users. And that's, yeah, it's an interesting, I think, consideration as we start to design our next round of systems, and how we expand our JupyterHub deployments as to what we want to leverage. I will say there's a lot of free lunch with the Epix community, right? They're providing some or either rich experience, but also some free lunch with like the Phoebus, I should say Phoebus community more than the Epix community, of like these generations of engineering screens and sort of service meshes that surround these engineering tools, right? So there's a lot of infrastructure that community has built that I think it would be hard to rebuild.
Awesome. Two quick questions, maybe one quick question for you, Yuvi, from our audience. There's a question about, is there any local to hub equivalent for PyCharm? And I'm personally curious, any other IDEs in the works, things like, I know Positron's like the hot new one right now.
Yeah. So the SSH support is very agnostic to anything. I know that PyCharm's remote development is also just SSH based. So I haven't tried it, but it should just work because there is nothing VS Code specific about that VS Code remote integration, right? And that's why we actually picked OpenSSH as a server, because that's what everyone tests against, right? Like what else does, it's not a random custom one. So it should work. And if it doesn't, because of the way the server is configured or something, please open an issue and we can either, make a knob or just like change the defaults so that it works for that as well. Yeah, and Positron is like a reskinned VS Code. So I would just assume that it works there.
Excellent. And then another question about the advantages or differentiating features between JupyterHub and something like Open On Demand, if you're familiar.
That's a great question. I'm not familiar enough with Open On Demand, unfortunately, to be able to really answer that. But if other people are, I would also love to hear that.
Dan, Phil, ever used Open On Demand?
I have
No.
not, but I
First
will,
time
I
I
will
heard,
jump
I
in
think.
with extra questions if, if we're seeking a pivot.
Absolutely. Go ahead, Phil.
So I had
Before
two.
that,
One,
Phil, sorry, I'll just say that the only difference to me from Open On Demand is that the JupyterHub community is pretty large because it's so diverse, right? It's like students, instructors, researchers, everyone, and we're all solving problems for each other. And to me, that ends up being one of the major differences, which is like social, right, rather than like technical. But that also has a flip side, which is that you may have a tool that is hyper focused on one problem and then solves that better. Right. So it's like trade-offs. I don't ever expect JupyterHub to be the one tool that works for everyone, but the goal is to sort of like be broad and be a pool where multiple kinds of people who would not normally think we are all using the same tool can contribute towards that, and then we can manage that. So that's sort of my like broad response without knowing about the specifics of Open On Demand. So sorry to cut you off, Phil.
no, that's perfect. It's good information there. I say I have one technical question that's more along the lines of sharing and security, right? So you had this great demo of, okay, you're developing a quick web application. And what happens in the situation where you're collaborating with a team member who naturally doesn't have access to your home directory? What are your clear routes for sharing that or collaborating on something like that, to get sort of maybe like fast feedback on a UI that you're developing? And then what kind of accidental risk does that open up, right? Because like I'm seeing that it's like, okay, like now do I have to allow groups of users to access each other's sort of new spawned containers on Kubernetes that are like that's using their kubespawner? How do I manage that as a sysadmin without opening up too much risk? And then how much risk do I have for like accidental maleficence, right? How do I stop future me from getting into trouble?
Right. So that's an excellent question. So the ongoing development in the Jupyter ecosystem. So JupyterHub is OAuth everywhere, right? Like everything is just OAuth. And the way you would deal with it in OAuth land is scopes. And so one of the things that has been happening in the Jupyter ecosystem over the last 18 months or so, and this is really driven by real-time collab and the need for real-time collaboration in JupyterLab to be able to have fine-grained permissions to be able to do this, right? And so what that has led to is development of the fine-grained permission system across Jupyter and JupyterHub that is really OAuth scopes. So as an admin, and I think the UI for that was just merged like a few months ago, recently, I want to say. And so as an admin, the way you would think of this is you would just set up appropriate scopes, and so that people in a group can share with each other, for example.
Okay.
And then, you would have a scope that would only not allow them to share their Jupyter lab, right? Because that's arbitrary code execution, but allow them to share, like maybe proxy prefixes. And after that, your accidental foot gun is just like the quality of your code, right? And what that allows you to do, right? Because if you're just giving them access to Jupyter lab, well, Jupyter lab allows you to do everything. But if you're only giving them access to a subset of things, well,
right,
that's
subset the tooling, but also you can subset on a path basis, right? And so you
Right.
say, hey, if you're developing a test application, right, it has to be under the prefix, /test apps /
something like that, right? Or just whatever. There's different ways of dealing with that. But this is all new, right? Like because it's just being worked on. I think a lot of the underlying heavy lift, which is around these scopes and making sure that they propagate and stuff, has been done. But what's still missing is sort of the community of practice work, right? Of like, all right, we're gonna play with this, and this is sort of like how the user experience works really well. This is sort of how the user experience is nasty. This is sort of how, like we can do this so that admins have confidence, because confidence is so important, right? So, yeah. So does that sort of answer your question there?
Yeah, no, absolutely does.
Yeah.
I had a related question of what's the status of the support for is it conflict-free or conflict-free data structures? Y.js. I'm mangling the acronym. Jupyter Lab had support for multi-user editing.
Yeah.
And then there was some, what I'm talking about? How does the hub engage with that at the moment?
So it's gotten a lot better. So Jupyter Collaboration is the package that has all of that code inside Jupyter Lab. and they just made a release, I want to say 2 weeks back, that includes UI for allowing you to share things with other users on a JupyterHub. Until then, it wasn't JupyterHub aware, but now it is. So I know.
That's huge for us.
Yeah, yeah. The GeoJupyter project had a hackathon a week ago where they used this, and it was like fine. So I think now it's in a place where you can play with it, and then report bugs. Because until they merged the UI, it was like, oh yeah, you can share someone the token. Here is the command line you can use to get yourself a token, and it's just like. Right, so nobody can use this. So try out the UI, report bugs, and then just sort of like we can see where that goes. But yes, it's JupyterHub aware now.
And would the scopes be of any use to say, I'd like to let somebody in to help me, but I don't necessarily want them to have arbitrary code execution running as me?
Right. So Jupyter Lab is also authorization aware to some extent now. So the question basically becomes like, does Jupyter Lab have support for scopes that let you do that, right? So that's sort of I don't have an answer to that question because I've not kept up with the Jupyter Lab stuff. But Jupyter Lab would then need to be able to say, oh, this user only has these scopes. So yes, I will serve them GET requests on the file so they can see it, but I'm not going to allow them to execute anything or whatever, right? Like, so that would need to be on the Jupyter Lab level. And this also means, for example, like RStudio doesn't participate in this, right? Because it doesn't really take advantage of the scope stuff. So the most that we could possibly do is to say like, well, you don't have access to RStudio, but nothing specifically inside RStudio unless they implement authorization themselves. But that's sort of like an essential complexity of how this works, right?
So to summarize this back to you, and this has been a long, long, long time in coming. The key pieces were OAuth everywhere, fine-grained scopes, James put in their conflict-free replicated data types, and finally the UI elements to make it actually accessible. And it's early days for that, but the pieces are now finally there.
Yes, and I've just pasted in chat the pull request that merged that, and you can also see a little snapshot of the UI there. So yes, this has been a long time coming. Long time as in 2016, I want to say.
I think that's right.
So when the first implementation based on a Google Drive API was almost done, and then Google killed that API. Fun times. Yeah. All right. And I pasted the link to the PR over there, and you can see some of the scope config that needs to be added there as well.
Thanks.
Excellent. A unrelated question to what we were just discussing, but from the audience, we had a question about Jupyter Lite and how that fits into the roadmap of future Jupyter.
Yeah, that's a great question. So Jupyter Lite is the WASM-based setup, right? Like, so where you're, instead of spawning something on the cloud, you're basically just what are you doing? You're basically compiling all of your Python and everything into a WASM blob and downloading that onto the end users. My perspective is that it's a slightly different use case. I do think it can take up a good chunk of the teaching use cases, especially early on. If you're just like, all right, here's some NumPy type stuff that you want to play with. But ultimately, I think, it is going to slot in over there. And I think it can replace some of the work that mybinder does because it's ephemeral, right? Like, while if you want to have sort of like persistent storage, more compute than the user's machine would allow. Like, one of the stark differences that we saw at UC Berkeley was that on a JupyterHub, someone with a $3,000 MacBook and someone with a Chromebook they borrowed from the library are equal, right? Because they have access to equal amount of resources, which is just not the case otherwise, right? Because like, what do you like? The Chromebook situation is quite different. So you will like that sort of comes back a little bit with WASM, right? But of course not to the same extent, but only because a Chromebook is so powerful these days. So I do think it will sort of like be very helpful for some teaching use cases. But I don't think it's going to like fully replace that, replace all teaching, nor like all research. It is using most of the Jupyter work. And at some point I started working on binder which would basically, like let you take a repository and just like automatically pre-install all the packages. But that's sort of like in the mothball somewhere with 400 other uncompleted projects. And yeah, like documentation, just like a place for you to like try out things. I think Jupyter would be absolutely excellent at. And it is going to be an order of magnitude cheaper than running a JupyterHub, right? Because it's just running on users' computers. So from my perspective, the most important things that Jupyter enables is things we don't know about yet, because that's what usually happens when something becomes an order of magnitude cheaper, right? Like things that we wouldn't have thought of as doing before suddenly become worth doing. And I think, like, yes, some of that will be documentation, some of that will be teaching, some of that will be things that we don't know of yet. So yeah, we'll see.
Yeah, absolutely agree there. You're getting a lot of love for Jupyter Lights for documentation and things like that. There's been a couple of projects that I've seen, not necessarily use Jupyter Light, but kind of the pi-iodide underlying tech there to enhance their docs. And I think it's been quite successful just actually being able to click run this code and then be like, I'm going to change one line. Does it still work? And then I will also say to the individual who asked that question, we did have Sylvain Corlet back in December, and he spoke a lot about, he was all about WASM stuff. So you can see that talk there in the link in the chat.
Yeah.
Any other question? Oh, yeah, Yuvi?
I see another question in the Q&A part of Zoom here. I didn't know that they had a separate one than chat.
Yes, absolutely. And so for our audience here, have you seen a case for remote JupyterHub hardware development, compiling firmware or using Platform IO, Circuit Python, and then connecting a device to using the browser's COM port to flash directly to a device or to communicate with it?
So we did do this in the early times of the pandemic, again, for another electronics class at UC Berkeley. Chrome and Chrome alone supports the Web USB standard, which is a terrible idea. Don't do it, because it basically gives arbitrary JavaScript on web browsers direct access to your USB. And that's not a security model most USB devices are designed for. But in this case, it allowed a Python package in the notebook running on JupyterHub to be able to emit JavaScript that could then talk to a physical device that was shipped to the students, wherever they were. So they could literally, work on the JupyterHub and physically plug the device in. So I don't have a link to that right now, but I think if you look for Jupyter Web USB, that would work. And I thought that was an excellent and amazing idea that worked pretty well and was fully developed by some of the TAs, right? Because it didn't require us to do anything on the JupyterHub side. It's just like something that Notebook does because of the way that it it's just JavaScript, right? So that worked out really well. Although I did want to then build like a web USB to like USB on the server side bridge, which would basically require you to write a USB driver that we can load on the server side that would then use WebSockets to talk to Web USB. This would be like a fun project for someone who wants to both write JavaScript, sketchy security things, as well as a kernel driver. Actually, that feels like the perfect fit for a don't use the code type like presentation for someone to build. So anyway, hopefully someone builds that.
Any final questions from our host panelists or audience to help round us out?
What are you most excited about for the future of JupyterHub?
Python has been a pretty inclusive space, but I think we can do so much better. There is, like R, I think has a different inclusivity story. I think there is a large swath of people who do data science work, but don't consider themselves data scientists just because of the way that this is being defined and who are the people who just happen to be the people first doing data science, right? And as we bring more and more of this to be first-class citizens, I think the tent gets bigger and bigger, and more people will be like, oh, that's what I do. I didn't realize I was a data scientist, right? And then both be able to support them in a way that is first class without admins basically just like losing their minds. So that's sort of like a social answer, right? Like that's sort of what to me is like sort of the most exciting. And there's definitely like technical things that work towards that. And the blog post that was shared earlier is one of the things like that I'm excited about. The existence of the Jupyter Zulip is actually the next most exciting thing for me, because I think community spaces are really important. A real-time community space is really important. And a real-time community space that is publicly accessible to everyone is extremely important. And, IRC is basically dead. Slack is super gated, and you lose things after 90 days, which has its own problems. So Zulip has been extremely helpful for the Jupyter project as a whole. So I highly encourage you to come and hang out and say things there.
Awesome. And then James, did you have an additional question there?
I regret to bring this up, but notably missing from what you're looking forward to in the future was anything related to generative AI or LLMs, which are the topic that nobody can stop talking about these days, and I know is driving us all sick. Is there a particular reason for that? Is that because you clearly looked at this and said, this is not really going anywhere, or is that the case that this is outside the scope of what kind of things that you've been looking at?
So that's a great question. So there's two answers to that. One is, there is the Jupyter AI project that is doing this in the Jupyter Lab side. And so when I looked at it, I'm like, right, I don't actually know what JupyterHub needs to do this, right? It's just like in the Jupyter Lab side of things. And they seem to, it's basically an AWS project, right? Like AWS is putting people onto it because of SageMaker. And I'm like, so I haven't really like touched on that because, I'm like, okay, do we need to do anything in the JupyterHub side to enable people to do this? And then the answer turned out to be no. And then, so that is sort of like the project answer from a JupyterHub perspective. And without a project or without a 2I2C or anyone other than just a Yuvi hat on, it is really difficult for me to like engage with the AI companies without thinking about the AI companies. And so I sort of like kept away from it, and I'm sort of like waiting for the bubble to burst, so we can actually build more useful tools with it without having to be like, I know this and that, but it is so useful because it is such a useful piece of technology. So for me personally speaking, only as myself, I'm waiting for the emotional valence of this to like tone down, so that I can engage more with that. And in the meantime, like, I think it's really important to continue to keep building a really big tent that solves problems for everyone, and that like the ultimate problems of open source and in general everything is really community problems and people problems, right? That's not going to change no matter what happens. So I'm like, right, let's continue to put effort into that, and that's what I'm doing.
Awesome. Well, it's very exciting to hear all about Jupyter, all about the features, but also the community that you're trying to build behind JupyterHub. So Yuvi, if you have that Zulip link and you would like to invite or paste in the chat, do feel free. And while you do that, I'll go ahead and round us out. I want to thank all of our host panelists for their thoughtful questions today. Of course, I want to thank Yuvi for joining us for the amazing Jupyter demos, as well as the very insightful answers. And of course, our audience for joining this month. Keep an eye on our webpage, that's meetup.doepy.org, for information about our next month's exchange. I want to thank you all one more time for joining, and I hope to see you around next time. Thanks, everyone. Have a great rest of your day.
Thank you.